Yes.
I think everybody miss the point of NASA. A lot of point people miss space exploration is not about only space exploration. Space
Mhm.
exploration is the birthplace of every technology we have, even why I'm talking to you right now.
Mhm.
Like it's
Mhm.
not about like going to space. I mean, like, your cell phone, half
Mhm.
of it have space technology. I mean, we developed solar panel for
Mhm.
satellite.
Mhm.
We invented CCD cameras, for space, for satellites. We invented like, we advanced radio communication for
Mhm.
space. So a
Mhm.
lot of the space technology come back, So like when people are like, oh, space is so advanced, yes, it's because we push the limit.
Mhm.
We know how electronics behave,
Mhm.
like going into space is gonna actually. There's one thing most people don't understand is like we could have solar storm tomorrow that could
Mhm.
destroy most of the electronics, but
Mhm.
I actually know how to design electronic to survive that,
Oh
because
wow, nice.
in space, we're not in space,
You
so
already
we have to
planned. You already
survive.
planned for that,
So
not like the rest of us. Loay Elbasyouni, welcome to the podcast.
yeah, thank you for having me.
Thanks. So, if you tell the audience about how you got interested in aerospace engineering.
Yeah, so actually my background is a little bit, I'm an electrical and computer engineer. And I studied computer and electrical engineering. Since I was a child, I always was really into electronics and, like figuring how things works. I mean, I was into computers. I probably built my first, worked on some of the build my first computer when I was 16. I mean, I fixed TVs, I built antennas. I mean, but when I was really young, I was actually wanted to be a pilot and
Hmm.
fly the space shuttle. So, I mean, but I didn't really think that's possible for me, so since
Hmm.
we didn't really have a space program. So, I love things that go fast. When I came to the US, I actually started studying computer science, then I switched to hardware and I studied, like electrical and like hardware computer engineering. And like then I studied robotics, and I got my master in control systems and electromagnetism. And then I started working. Actually, I worked in power electronics because I really wanted to change the world. So I worked on a lot of electric cars, and so
Hmm.
that introduced me to mobility. Autonomous system. And from there, I worked on a lot of drones. So a lot of people don't know that I probably, I mean, helicopter of Mars is like one of the many flying objects I really worked on,
Hmm.
and but
Hmm.
my specialty actually like would bring in, I think a lot of people do not see it. It's like, it's like, it's my knowledge from like from the high power electronics all the way to the computing and actually
Hmm.
also the algorithm development. So it's like how you develop algorithms, and like for like controlling the motor because that's really gonna be your main source of motion
Hmm.
in like the helicopter. So I was leading the helicopter. I led the electrical engineering portion, which is including the motor design.
Hmm.
The motor. I designed the motor controllers. I worked on the motor algorithms. I worked on
Hmm.
in the selecting of computing.
Wonderful.
In some of the computing architecture that actually was used inside of the helicopter.
Wonderful.
Yeah.
Excellent. What an interesting journey to aerospace engineering. Before getting into what you have been doing recently with your startup and prior to that, Blue Origin and NASA, if you could just tell us a little bit about your upbringing how it has influenced you to become what you are right now.
Yeah. So I mean, one of the biggest thing influenced me is actually there is a trend in the Middle East that people cannot do things. So since I was really young, I always like believed I could do anything. I mean, like like we had a TV, it would stay broken for years or months. So I started just fixing things. So I mean,
Mhm.
but like the general notion of the entire, I think, culture,
Mhm.
or like society is like they believe there's certain things they cannot do, and
Mhm.
so I think that's really, I think that's kind of like that's the barrier I broke probably really young. I mean, I
Mhm.
just started reading a lot about a lot of different things. I mean, I did a lot of different things. I mean,
Mhm. Mhm.
I
Mhm.
probably did a lot of stuff in agricultural engineering. I used to like look at trees and know what the disease they have
Mhm. Mhm.
just by reading books. Just read something like the toilet broke down, I'll fix it. Just
Hmm.
I'd rather just fix it than hear, my mom complain to my dad, like, call the guy, call the guy. So I mean, it was the same thing, I wanted to, like, our antenna stopped working, I fixed the antenna, then I
Oh
discovered
my
I was like,
God.
I can make my own TV station, because like accidentally I connected the amplifier
Awesome.
back, and all of a sudden I'm broadcasting the Atari games over the net, right? So I mean,
Amazing.
but it's like I think that believing that you can do something, and then along the way you discover. A lot of people, I think, think that they have to know where they're going, they have to know what they're exactly going to do, and
Hmm.
I mean, and that even applies to when you start a company. Sometimes you have
Hmm.
an idea, but you you have to be flexible, dynamics, and you're going to discover things. Even
Hmm.
engineering, there's many things discovered along the way. It's like while you like designing something, and then all of a sudden it's like, oh, this is a better way of doing it. But like until you start, until you believe you can, right?
Hmm.
And you could probably fail, but then you pivot and you succeed. Until
Exactly.
you try, you will never reach it. And I
Exactly.
think like growing up, like in a farm, I grew up in orange groves. Like we just took care of trees. Like I started working at a really young age. I mean,
Hmm.
probably like 7 or 8. Started
Hmm.
helping my grandfather. And so I think that like made me like love working with my hands. And say
Hmm.
when I come home, I mean, I started like I couldn't have everything. I mean, we were not. I mean, my dad was a doctor, but wasn't. We were not like really well off. So like I wanted to have a walkie-talkie, so I'll go buy a bad one, with
Hmm.
like for like not even $1, like, and then like just fix it, and then I have like four walkie-talkie, when no kids had it. I was like, oh, I don't have one, you're rich. And I was like, you have no idea. I literally bought it from the junkyard. So, but I mean, so and but I think I think that's really like what made me like always believe that I can. I mean, I do still think I can do anything. I can put my mind to it.
Hmm.
I mean, people know me closely know that about me. It's like,
Hmm.
if I put my mind into something, I'll do it. So, I think that's a really, and I think a lot of that was driven by, a lot of people around you like did not really have that. And I think once I discovered that, I like, I felt I have this a little bit more power.
Wonderful, wonderful, mashallah. So basically, the desire to fix things and curiosity, and also belief in yourself that you can do anything that you set your mind to. Another quick question about your upbringing as well. In one of the podcasts, I learned that that interviews that you had, I learned that I think your father wanted you to be a doctor, but then somehow you were able to convince your family that you have amazing engineering skills and this is how you became an engineer. So if you could just elaborate a little bit on that.
Honestly, yeah, my father wanted all of us to be doctors, but I mean, my father's not the kind who forced, he kind of guide
Sure.
you and let you choose.
Hmm.
But but one of the biggest thing is like, like my father actually saw my engineering abilities. My
Hmm.
uncle was like, "Oh, you should be an agricultural engineer." My other
Hmm.
uncle was like, "You should be electronic engineer because you're fixing things."
Hmm.
I was like, "Oh, you're really good with computer. You should be a computer scientist." So everybody like because they see me doing something. But my father said to me is like, because I really wanted to go to Germany at that time. I was like, I
Hmm.
think you should go to the U.S. because I think you are an entrepreneur. You are like literally have a business strength and you
Hmm.
really don't like studying,
Uh-huh. Uh-huh. Uh-huh.
you know. I was probably not the best out of all my brother in my grades. I mean, I
Hmm.
understood everything, but I like to apply things.
Hmm.
And so my father like thought if I go to Germany, I might not have succeeded
Hmm.
because I'm not like So he thought I was a better fit for the U.S. Because like
Hmm.
it doesn't have like the entrepreneurial culture.
Hmm. Hmm.
So I
Wonderful.
think that's the reason my father kind of actually guided me to come to the U.S.
Excellent.
Even though I
Excellent.
was studying German at the time to
Hmm.
strengthen my old German because I mostly forgot. But
Hmm.
yeah, so
Fantastic, fantastic. Okay, so then you made it to the US. I think you had a bachelor's degree there in computer science or electronic engineering.
yeah. So actually, my degree is in electrical and computer engineering. I have
Wonderful.
a bachelor and I got a master in
Hmm.
electrical engineering. And so mostly in like control theory and electromagnetism, and then actually started doing another master in
Hmm.
computer science. And
Hmm.
so I mean, I worked many years also in computer, like IT. So so I mean, to me, computer was like, like the easy thing. That's why I wanted to do more things with hardware. That's
Wow.
what got me actually more into. That's what actually led me to the career where I am.
Mhm.
Like how to control things. In the most. You have to be the most efficient way.
Mhm.
Computing. It's like computing. I mean, even power electronics. You have to compute things extremely fast, like a lot of processors. Even you cannot use OS, like,
Mhm.
for motor control. Like, you have to really run things natively. I mean, I worked with things like with assembly code. Even to this day, I mean, computer cannot respond fast enough to a change in electric current. And from there, that's actually led me into like, I mean, over the years, I mean, I did many different things in power conversion.
And do you think right now and we're getting closer to more affordable trips to the moon, for instance? Like, do you think soon enough we're gonna have like touristic trips to the moon?
So
Yeah.
yeah, so I mean, I could probably speak more free on this thought. I mean, so like there is this whole new, like the Artemis program. I'm not sure if you're familiar with it. So the Artemis program is actually it's the NASA program actually to the return to the moon. So it's
Hmm.
not just about going to the moon. So it's completely different than the Apollo mission. It's not about going one time to the moon.
Hmm.
Apollo, like the Artemis mission is like it's actually is about the idea of going to the moon and creating a system. And I
Hmm.
said what I mean by that is like,
Hmm.
so like, that's why they had like SLS rocket. They also have Starship, and they're also going to have New Glenn. So it's not about New Glenn or Blue Moon
Hmm.
or Starship alone or the SLS or Orion. So also there's the Gateway. So Gateway is going to be like almost like a space station around the moon. So eventually you're going to be able to like launch things, go to the moon. There will be a base on the moon that,
Hmm.
you could probably like use to manufacture things,
Wonderful.
to manufacture rockets, to like create fuels, to send missions from there to Mars. So it's not like going to the moon. It's not only about going to the moon. It's
Excellent. So it's
about making it
building an
easy to go to space.
infrastructure. Yeah. Yeah.
Some of the things I read about in the Artemis program is like, I mean, the plan is to almost have a monthly trip,
Hmm.
actually going to the moon, and it's going to be like at least from the gateway to the moon, because, they're going to be transport. So, Blue
Hmm.
Moon's supposed to be working fused with that.
Hmm.
Like there would be like some kind of probably mining activities on the moon to like, utilize some of the resources, manufacturing of solar panels, probably like try to figure out if they can like, use methane from the moon to use as like, to refuel the rockets.
Hmm.
Because, launching from the moon is a lot cheaper than launching from Earth. So like just by actually being there and
Hmm.
being able to send things to the moon, it will make going to Mars possible.
Okay, could you explain to again the average person why launching from the moon would be? Is it like lower
So,
gravity
so like, no, the gravity on the moon is like 1/6 of Earth.
Mhm,
So,
mhm, mhm,
that's a lot easier to get out of.
mhm,
I mean,
mhm,
like, like it take about, like, you see, like you hear about people reaching space. I mean, that's
mhm.
kind of like whatever, I mean, like seriously,
Uh-huh,
I mean, the German, nobody know this. The German, the first one to been to space, not as
uh-huh,
a person, send a rocket to space in
mhm.
1941. They
Oh
reached, I
wow.
think,
Okay. Okay.
yeah, they reached like 120 or 160 kilometers. I don't remember the exact number
Mhm,
now.
mhm,
Van Braun, like with the V2 rockets, which is,
mhm,
was
mhm,
used as a weapon in World War II.
mhm,
But
mhm.
so I think nobody want to give them credit for that. But, so I mean, they broke that Kármán line. So, but the thing is, like, once you leave the Kármán line, that they say, okay, you're kind of in space, but to get from there to orbit, it'll take you about 10 times more energy.
Mhm,
So imagine this rocket you see getting to space, like, oh, we reach space,
mhm.
fine. But like try to get to orbit, you need 10 times more energy. So that rocket
Oh
has to
my
be 10
God.
times bigger. That's
Uh-huh,
why if we like, look at like some of these like low Earth orbit, like low Earth like launch rocket, like New Shepard,
mhm, mhm,
like
mhm,
it's a lot smaller compared to the other one. It only have like one engine versus
mhm,
you know
mhm,
versus the other rockets have like like I mean I don't know like a Falcon how many engines it have.
mhm,
So but so I mean that's where it's the difference. So when you're on the moon now, like if you can make some things on the moon,
mhm,
like like making fuel on the moon, then you don't have to carry the moon. So if
mhm,
you look at it going to Mars, so I mean if you want to go to Mars right now, it takes us about 7 months, and
mhm,
that's a time window every 2 years it opens, so
mhm,
every 2 years you get a chance to go to Mars.
mhm,
So during this and you have to take you 7 months. But if you think about a human being, if you want to send a human being to Mars, that's like I was talking to my dad about this. I think if a human, you need about a kilo to a kilo and a half of weight of food, and you need about
Yes.
at least a liter of water, right?
Oh my God.
It's
And
like,
then you
so like
calculate everything by the
imagine now
gram. Yeah.
how many days in 7 months? So that's like 30 times seven. That's what is that? 220, 210 days, right?
Hmm. Hmm.
So just to go to Mars, so you multiply that by two. That's about half a ton of food and water
Oh my
for one
God.
person.
Yeah.
A rocket to space, a lot of them carry like 2, 3 tons.
Yeah. 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 Yeah.
So they'll give you when I send a team of 5 people, do the math. You might have to send with them like 20, like 12, like I think like it's about 20,
Hmm.
20, 24 rockets. I
Hmm.
think they're. And it's been a while since I read the book of Van Braun
Hmm.
about this Mars project. You talk about how many to send all the supply you need. So
Hmm.
that's why I think the mission to Mars like didn't happen because it's just like take a lot more resources, and a lot
Exactly.
more cost. And
Hmm.
we don't know the consequence. I mean, we
Hmm.
don't know how
Hmm.
that affects human life.
Hmm. Hmm.
We
Hmm.
send people to the International Space Station, they come back
Yes.
aged so many years. So
Wonderful. I wanna go back to and mashallah your creativity and ingenuity. So we skipped the part when you got admitted or you joined NASA as an aerospace engineer. How did that happen? And then also describe the project that became very popular, the Ingenuity helicopter project, and what was
yeah,
your main contribution to that project?
yeah. So like Mars, the Mars helicopter Ingenuity.
Mhm.
We used to actually call it Leonardo in the beginning. So
And why did you
secret.
change the name? Why did you?
I think that was the team name. So NASA really
Oh,
wanted to like
oh, okay.
allow students, so they have a student competition for
Got it.
naming it.
Oh, okay.
So I think one girl won the name.
Hmm.
Like she came up with the name Ingenuity. So
Hmm.
I mean, just to inspire kids. I
Sure,
mean, so
sure.
um, but so I mean, Ingenuity is like I mean one of the biggest things. It's not about like a lot of people like oh you work for NASA, so cool,
Hmm.
or you send stuff to space. I mean, Ingenuity is basically like the Wright brother. So I mean, I feel like I'm
Hmm.
so proud to be of the Wright brother who made the first flight on Earth to be part
Hmm.
of the team that made the first flight on Mars possible.
Hmm.
I worked on the helicopter from about 2013. I
Hmm.
mean, like when we first did the first feasibility study, that was like to prove that we could fly on Mars, and we did the mathematics just on paper, and actually
Hmm.
we won actually an award from NASA. I won an award from NASA on that,
Hmm. Hmm.
because like we proved what everybody thought it was impossible on theory. It's like yes, we could do it, we could build something, it have to be this way,
Hmm.
and and then it's like based on that we started the development, and it was like I mean it was a really challenging project because a lot of people did not have faith in it. I
Hmm.
mean, even NASA, some people in NASA did not believe it was possible. Is
Hmm.
because the air on Mars is like less than 1% of the air density on Earth.
Hmm.
So, and we know on Earth is like we cannot really fly helicopter above like 40, 50, 40, 50,000 feet. And that's actually very rare, special helicopters,
Hmm. Hmm. Hmm.
very lightweight load. So we had like I started actually I was the electrical lead from literally from the first day when we built this small toy.
Hmm.
We called it like basically the flight demonstrator just to prove that we could fly, and we flight and we actually crashed it.
Hmm.
If you probably seen the videos, like it just jump and hit the ground. That's because
Yes.
what we determined was extremely, now we
Hmm.
get into the computing, was extremely hard to control it with a human
Hmm.
reflection, reaction, because, like you needed like a 500 hertz bandwidth on the loop. So you have to,
Hmm.
respond so quick. So that we determined it have to be completely autonomous.
Hmm.
We couldn't really have interference in it. Plus there's a delay in time. So
Hmm.
I led the electrical and power electronics. So that include the system includes avionics, and it includes that include the motor controllers, servo controllers. There's like three servos in each prop. There's two motors, the motor controllers,
Hmm.
also all the wiring. Also worked on the computer algorithm,
Hmm.
how to control the motor, because we had to control the motor in a specific way. We custom built the motors, the main propulsion motor. And so I worked on all of that, over the years. So I mean, on and off,
Hmm.
I was working on other projects at the same time. That was not the only thing I worked on. I
Hmm.
probably worked at the same time 12, maybe it's like 16 more drones, and during the same time period. So,
Mhm.
and, a lot of them are pretty cool too. But
Those were also part of NASA projects, the drones.
no, so yeah, I mean, yeah. So I mean, it's not. No, that was not. That was like for different government,
Okay, sure.
different government agencies.
Hmm.
But
Hmm.
so yeah. So I mean, I don't want to talk about it, but you probably
It's okay.
see.
Yeah, let's focus on the Ingenuity helicopter. Yeah.
Yeah. So, but yeah. So I mean, So yeah, but so I was working like closely with like the teams,
Mhm.
like
Mhm.
at JPL, the
Mhm.
teams, and that interfacing with a lot of the different teams, from the actual software programmers, the robotic guys, like
Mhm.
the computing. So and how, and then it's like also like the space radiation team, because we had to. The biggest problem was like to meet the weight requirements, we had to really figure new ways. So I mean, I came
Mhm.
up with the idea of like, why couldn't we use automotive parts? Because I mean,
Mhm.
I worked on electric cars, so like I like the automotive world,
Mhm.
because I mean, I think the automotive world is extremely reliable. Produce
Mhm.
a lot of parts.
Yes.
So so we came up with a method of like how to actually use like standard like earth rated products like electronics for space.
Mhm.
And so that was so that actually made us be able to achieve the weight target. And from there, like I worked all the way until like we did the first the test flights and all of that.
Mhm.
So
Mhm.
I mean it was an incredible journey. It was
And then
stressful at
and then
times.
yeah, sorry to interrupt you. And then when the helicopter was launched, it got to Mars and it stayed for what period of time did it stay there? And it was much
Yeah, so I mean
better
honestly,
than not
so
much more than what you expected. Yeah, tell us.
no, I mean so it's actually it doesn't matter how much I tell you, because the feeling of the
Of
helicopter,
course, yeah, tell
like
us.
even from the first day when we worked on it, I was like, man, I really want this to go to Mars.
Yeah,
Just
yeah.
to say I have hardware in Mars. Like I wasn't even like, even if it didn't fly, and I was like, I'm working on this. It's like I could
Yeah,
have something with my name on it on Mars.
yeah, yeah, yeah.
Like so when we got there, I mean, actually it took us 2 months before we took the first flight. When I could not say it's like I was like very optimist. I mean, I was
Mhm.
like,
Of course.
I hope
Yeah.
it fly. And my friend texted me, it was like 4 a.m. I was just like, it's just an incredible moment. But
Mhm.
and then it's like, I see them like operating like past the month. I mean, we
Mhm.
went from like 5 flights 1 month to
Mhm.
fly like 2 years, or 3 Mars years,
Oh
to
my
survive
God.
3 Mars winters, which we did not design it to survive the Mars winter.
Uh-huh. Uh-huh.
So they
Uh-huh.
had to have a lot of design changes to it,
Mhm.
and so I mean, it's incredible.
What
Not
what
only
what
that,
what made it have this great success? I
I mean,
mean,
honestly, like I mean, we designed it with margin. Everything I designed had a little bit of margin on it, but
mhm,
also I think I mean, I think everybody who worked on it had an extreme passion to make it succeed.
mhm,
So
mhm,
like it was personal, honestly. Like I think everybody who worked on the helicopter, if anybody hear this,
mhm,
like probably everybody felt it was personal, because
mhm.
like a lot of people, like you work on projects sometime and they get canceled, and it's like you take it
Of course,
personal.
of course.
Like it's like, oh man, why they stop the funding on this? So like we had to like prove every single phase to get
Mhm,
to the next phase.
mhm,
So
mhm,
that I mean, we only built 3 helicopters, like the EM1, EM2, and FM. The one on Mars is the third one.
mhm.
You know, so like and if you're an engineer worked in a company, it's like hey, I got a product. It's not it's serial number 3 is on Mars,
Mhm.
and the first two actually they're not even serialized, because actually serial number 1. But I mean, so it's like but then it's like they had to do changes, so they had to update software. They had to implement the AI algorithm for the landing, because in the beginning the I mean, to have autonomous. So now we're
Mhm.
getting into autonomous AI. But
Yes, 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 yes.
where but like so autonomous is like most other drones. Like you really like all the data getting from like the accelerometer, all the different sensors. It's
Mhm,
like helicopter or the aircraft is also decide
mhm,
where to go, what kind of RPM, how much to do thrust, all of that calculated intelligently. But
mhm.
then it's like we had to add, they added to it, like the image analysis. So basically analyzing the image to decide where to land. Because in the
Mhm,
first few flights,
mhm.
actually the rover was helping the helicopter to like finding landing sites.
Hmm.
because the helicopter was not capable of that. So that software was implemented later,
Hmm.
so to allow the helicopter like to fly and just like anytime it could just land.
Hmm.
So that made it actually go a lot more because we didn't have to hold the rover hostage. Because I mean, the rover is have a critical mission. It is actually on a mission. For the
Hmm.
helicopter, the technology demonstrator, at least in the beginning phase,
Hmm.
so which means like when you pay like a 1.2 billion dollar for the rover, I
Hmm.
mean the helicopter is just chunk change. It's like 84 million. I mean, it's not even important to the mission. So like they had to really have the helicopter function completely autonomous
Hmm.
independently. You just tell it, we just send it the data. It takes 4 hours to get there. You just like, please launch, fly, and then like you come, and then you can land, and then it's like you transmit the data. So I mean, I
Hmm.
think one flight it ended up landing behind a ditch, and we like
Hmm.
thought we lost it.
Hmm. Hmm.
And then we're like, wait, what happened to it? And then like 2 months later, it just like showed up live again. So, like even on the last flight, 72, we are like, oh, maybe it's still working. But then we
Hmm.
saw we got the picture. Apparently the AI, because like AI is all not perfect.
Hmm.
When it was trying to land, like sand is the same color, and with the reflection of light, it thought it was a flat surface, so it landed on an uneven surface, and then it actually ended up hitting the
Hmm.
sand.
Hmm.
So
Hmm.
we literally could not do anything even to
So,
avoid
so
that.
I have a few questions on this. They might
Yeah.
seem like a trivial questions to someone like you, but like, how did Ingenuity helicopter avoid, I don't know, like issues on Mars? Like, maybe there is a storm going on. Maybe how did it avoid conditions like that? And also regarding the AI. The AI requires computational power, which is extremely limited on a device like that. So how did it manage? How did you guys come up with this algorithm that does what's needed while saving the energy that's very expensive on a place like Mars?
So, I think the first thing for anything, there is needs and wants. I think
Mhm.
engineers always face this problem. Everybody wants everything, but
Mhm. Mhm.
there is need. So the helicopter actually used it's like a less than 1 megapixel camera for navigation.
Mhm.
And so like it does not really need a lot of computing power. It
Okay.
does use Snapdragon, which is
Uh-huh.
I don't know that's like on Samsung 3 or something. So
Uh-huh.
it's
Uh-huh.
pretty old processor. So
Uh-huh.
and have
Oh,
it
wow.
run Linux on it. So like that's what it's actually used for the flight,
Mhm.
uh, the navigation. It does have other processors, that have like TMS 570, does some computation on it, and then have a FPGA for the does the TMR, which is turbo module redundancy. So that's
Mhm.
how you go. If one of the other processors got a glitch or got a bit flip, you can reset it by the centralized computer,
Mhm. Mhm.
which is basically an FPGA. Because an FPGA it's easy to make things replicate.
Mhm.
So I mean, so like the thing is like we know, this is the minimum we need, so we just do what's the minimum we need,
Excellent.
and
Excellent.
you know, limited. So, and I think this is because I give a lot of talks about the helicopter, and a lot of time I get students, especially people, are like, "Why didn't you put an NVIDIA chip on it?" Like, if it did,
Because you
it would
can't.
fly. Because if it did, it would never fly. I mean, so
Mhm.
I mean,
Mhm.
you cannot
Yeah,
just do, and
simply
that's
for
why
simply for the weight, or is it because of the computational power
I
that's
mean, it's
available?
both. Because
Both. Okay.
both.
Both.
For
Okay.
computation, you need power. For
Mhm.
power, you need battery. For battery, you need
Excellent.
solar panels.
Excellent. Excellent. And all of that is not available.
You
Yeah.
know, so it's like, that's why it's like when you're designing it, it's like you could not design the computing
Hmm.
without designing the motor, without
Hmm.
designing the battery,
Hmm.
without designing the wire you're gonna put in it. Because now,
Hmm.
like you just add like, it's only 10% more, but 10% more is gonna add. We have 2 meters of wire going through the motor. It have to
Hmm.
be like now thicker, and 10 is like 10% more.
Hmm.
Square it to get the
Hmm.
current. That's like, if it is like 2 amps have become 4 amps. So it's
Yeah.
like,
Yeah.
the
Yeah.
one,
Yeah.
so
Yeah. Yeah.
like everything
It
like
adds up.
grow,
Yes, 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 yes. And the AI algorithm that was like programmed into the microchip in order to help the helicopter land and navigate. If
Yeah,
you,
that's so that's all done on the Snapdragon. So it does
Mhm.
have actually
Snapdragon. Okay.
like a stripped down version of Linux on it,
Yeah.
and it actually
Mhm.
run the algorithms there. I did not work on these algorithms
Oh, okay.
specifically,
Uh-huh.
so, but I just learned about it. That's one.
Amazing, 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 wonderful. And then if you could
I
also
do, I
tell.
do, I do believe that if you, there might be even there might be open source on on NASA's website.
Wonderful, wonderful. I'll check that for sure.
There's a
Uh,
lot of a lot of the things on the helicopter you can find in the.
Excellent, excellent. So that's one of the philosophies of NASA is to make things open source.
No, so not specifically.
Hmm.
So NASA does actually, when NASA was created with a mandate to actually allow all the technologies it developed being transferred to the private sector.
Hmm.
So and and academia, right? So anybody could license. So the NASA have like NASA technology transfer and NASA spinoffs. So a lot
Hmm.
of these technologies and patents, if they're really like high secret, then they like primary transfer to high secret programs. But there's a lot of stuff actually could even like it's open to the entire world. So
Hmm.
uh,
Hmm.
you
Hmm.
know, the data, a lot of the things about like a lot of it was published.
Hmm.
The helicopter was considered, allowed to be published. So most of the stuff on it, I'd say
Hmm.
about 95%, a lot of it is in the public, so you can build a helicopter.
Fantastic.
I don't know if you could build it, but
No, no, no,
you
not
could
me.
build the
Not
computing, but yeah, I mean, it's like I don't know. There's
maybe.
not stuff about the structural built on it, but
Mhm.
I don't know if there's anything about the motor or the motor controller on it. So
Sure,
in the
sure,
public,
sure.
but my
What
stuff is still kind of like hidden.
yeah, absolutely, absolutely. So, what's the significance of this trip, the Ingenuity helicopter? You said the rover was sending data back to Earth and so on. Like, if you could tell us a little bit, like, what kind of
So the
findings?
reason,
Yeah,
yeah, I mean, it's kind of cool idea to fly on Mars, but
of course, of course.
no, but I mean, it's like the rover is limited. If you ever watch, and I recommend everybody to watch a documentary called Oppie, it's about spirit and opportunity.
Hmm.
I mean, like you, like with a car, like you can
Hmm.
wander for miles, right? And
Hmm.
even like if you walk, like let's say I throw you in the, I mean, you live close to the, I mean, you live in the desert.
Yeah.
So if you get lost in the desert, and
Hmm.
I'll give you option as like I can give you two things, you
Hmm.
know. I think you are within 5 miles from a place that can save you, right?
Hmm.
And you're an engineer, and I'll give you as like I can give you a car,
Hmm.
but it only have 7 miles of range, or I'll
Hmm.
give you a helicopter that can only fly for 12 minutes. Now think about it. If you take the car, right, gonna go a 4 mile one direction, you could be 8 miles
Yeah,
off.
you're right. You're right. Yeah,
You
probably
take the
a
helicopter and
helicopter. A helicopter.
you
Yeah.
fly it up, right?
Yeah.
Or a drone, you fly it up. The
Hmm.
drone is gonna be able to see 20 miles.
Yes. 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 Yes.
So I mean that's why on a rover, the same thing on Mars. It's like on
Hmm.
Mars you cannot really
Hmm.
like you're not you don't the rover doesn't know where to go. So the
Hmm.
helicopter could assist mapping, could assist it like into like the small things like it could reach the bottom of the valley where
Hmm.
most likely to have life. So
Hmm. Hmm.
so I mean that's it's easy. It's easier to access places that like could be very challenging for a rover on the ground.
Hmm. Hmm. Wonderful. Fantastic. Okay. So we're getting closer to the end of the podcast. Right now, you have a startup. What are you trying to do in the startup? If you can just tell the audience.
Yeah, so I'm working in a company called actually Astraqua. We
Hmm.
actually work on robotics. Like, it's
Hmm.
going to be AI-driven robotics. We work on like swarm robotics. It's one of the
Hmm.
things, also some
Hmm.
of space technology. So
Hmm.
right now we're working with, NASA, trying to get some, we're working on some NASA grants, for a few different things. One of them is actually computing and AI.
Hmm.
Uh, Another one we're actually looking at, maybe actually building a power plant, a solar plant for the moon.
Hmm.
So
Hmm. Hmm.
but also like some of the biggest thing is like we want to bring in some of the technology we worked on space,
Hmm.
and bring them for like also Earth exploration, like into deep ocean.
Hmm.
That's why it's like actually the name like have the aqua in it. So because I mean we see a lot of synergy between space and ground, and
Hmm.
we could there's a lot of things I cannot really talk about it yet,
Sure, 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 sure.
but the idea is basically like kind of bringing things like space technology to be used for like Earth exploration, and also so
Excellent.
the focus is going to be like you know is go back to the computing and the helicopter. So a lot of it is based on the helicopter. The helicopter did a lot of its tasks on the rover or on Earth.
Hmm.
So I mean, if you think about that, that's like computing architecture. You could have the microcomputer with micro AI, and then you have and then it's like how to make a system like more dynamically that work, and to have multiple robots that could communicate. But then it's like you could decide what part of the computing happened on the robot, the drone, robot, underwater,
Hmm.
whatever it could be, and
Hmm.
whatever could happen on a centralized computer
Hmm.
nearby, and whatever could be done also on the cloud. So it could be multiple stages. So that's kind of really where we at right at this point. So I mean, I think it's going to be a lot of really cool things. We have really nice team. I have a lot of alumni from NASA helping me out on this, and
Hmm. Hmm.
uh,
And how do you feel AI is going to expand the field of robotics? I mean, will these robots become more independent, have more intelligence embedded into them to the point
well,
where they can make
I think
decisions?
there's
Mhm.
yeah. I think my thought is I think for two reasons I think that
Mhm.
AI on robots will be limited. One is computing.
Mhm.
Uh, I think that we'll overcome that, but also it's also for safety. I think
Mhm.
we're developing a system that's going to be very safe. That we actually limit the ability of AI on the drone itself.
Mhm.
So but versus like whatever could be in centralized. And
Mhm.
also like there is tasks that could be centralized. A robot like let's say you have a robot that collect data. I just want to
Mhm.
like let's say
Mhm. Sure.
flying drone.
Sure.
I have 10 of them, and I'm mapping a city with them,
Mhm.
right? Or I'm
Mhm.
actually looking for something, like doing
Mhm.
a search and rescue, like in the desert, or
Mhm.
so like just searching for somebody got lost,
Sure.
right?
Uh-huh.
So yeah, I could get all the data, right?
Mhm.
But these drones cannot talk together. So each
Why?
one, even if it is super intelligent, right? Even if
Why,
you
why,
put
why
like
can't they? Why can't they?
again, because a drone will only have the data it have. It does not have the data of another drone. So now if I have
Oh, okay.
10 working on a mission, right?
Okay.
It doesn't have the data from the other one. So some of that data have to be processed somewhere else. So it's gonna be like coherent robotics.
Okay. So like a
So like
drone
that
is like an
centralized AI.
independent, sorry to interrupt
Yeah.
you. So
So
a
like
drone is
yeah.
like an
So like
independent unit. Yeah. Okay. Yeah.
yeah, like I say, if I have images from nine, from
Hmm.
10, right?
Hmm.
But and then I have like GPS coordinate from all of them. I could put them into one central AI, and I was like, oh, we missed these spots. So like all of a sudden it's like task one to go do
Hmm.
that part.
Hmm.
So I
Hmm.
mean that's just like just idea, like
Hmm.
something
Hmm.
like So I mean it's not yeah, I can talk about it 'cause it's not that easy to implement.
Sure. Sure. Yeah, 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 yeah. I'm sure it's not easy, but mashallah, you have a lot of innovative and creative ideas. Before we end the podcast, that's something that we should do here. We should have as a priority in the Arab world to explore this,
Yeah,
invest in
honestly,
this.
I think everybody miss the point of NASA. A lot of
Mhm.
point people miss. Space exploration is not about only space exploration. Space
Mhm.
exploration is the birthplace of every technology we have, even why I'm talking to you right now. It's
Mhm.
like it's
Mhm.
not about like going to space. I mean, like your cell phone, half
Mhm.
of it have space technology. I mean, we developed solar panel for
Mhm.
satellite.
Mhm.
We invented CCD cameras, for space, for satellites. We invented we advanced radio communication for
Mhm.
space. So a
Mhm.
lot of the space technology come back. So like when
Mhm.
people are like, oh, space is so advanced, yes, it's because we push the limit.
Mhm.
We know how electronics behave.
Mhm.
Like going into space is gonna actually. There's one thing most people don't understand is like we could have solar storm tomorrow that could
Mhm.
destroy most of the electronics, but
Mhm.
I actually know how to design electronics to survive that.
Oh
Because
wow, nice.
in space, we're not in space,
You
so
already
we have to
planned. You already
survive.
planned for that,
So
not like the rest of us.
So I mean, there is like space is just, and also like you advance in technology. So you advance in metallurgy. So if you developing rocket engine, you develop industry for metallurgy. So like you start knowing how to make a metal. That's
Mhm.
extremely important for your industry. If you
Excellent.
can make rocket engine, you can make airplanes. If you can make airplanes, you can make cars. If you can make
Absolutely.
cars, you know. So I mean, there is like so many things that come down.
Mhm.
I think a space race, in the Middle East, I think would like actually it's my dream to see a space race in the Middle East.
Mhm.
Because I think that's gonna push the limits, and
Mhm.
also like it creates passion. I think a lot of kids like find passion. I mean,
Mhm.
like being an Arab, like like if you think of all the scholars,
Hmm.
in the Arab world, like a lot of the ancient like Muslim scholars,
Hmm.
a lot of them are astronomers, because like when you look at the stars,
Correct. Yeah, they have
make you
Arab
it make
names.
you think, it make you think of the future, make you
Yeah.
think of like, it make you innovative. So,
Hmm.
I mean, I think it is extremely important. It's not about, oh, I made it to the moon, or I actually have a satellite. I mean, that's good. It's gonna teach you things because now he's discovering things, and then a lot of these people, like I think, like yesterday I was reading a book,
Hmm.
and I finished with this. I was reading a book about like startups. It's like, it's called start, startup founders, like powerful startup founders.
Hmm.
And
Hmm.
it talk about literally like the list the companies where most startup founders come from. And I
Hmm.
think NASA's like, I think number 4.
Hmm.
So, so there's a lot of startups that gets created
Hmm.
from NASA, just because it creates this belief you can do it,
Beautiful.
and like that's
Beautiful.
just like, and I think that's what got me going is like,
Excellent.
like when I was a kid, it's like
Uh-huh.
you
Uh-huh.
can do it. If you really cannot believe you can do it,
You
I,
want
I
to.
think I probably just like, yeah, just don't waste your time.
Exactly. Okay, with that, let's end our podcast. Thank you so much, Loay. This was one of
Thank
the
you.
best conversations I've ever had. Thank you so much.
Thank you. Thank you for having me.